Chemistry time. Today we're talking about empirical and molecular formulas. I like to use the word formulae. Your book and almost all of the sources use formulas because it's easier. Anyway, it doesn't really matter. That's etymology, not chemistry. Empirical and molecular formulas. Always when you do one of these, you'll be given, the reason it's called empirical, this word, have you heard this word before, empirical? What's it mean?
Number.
Yeah, I mean, that's not wrong, but empirical, if I have empirical evidence of something, it means that I have real, tangible proof, right? There's a philosophy called empiricism, which just says that the only things that are real are the things that we can see and touch and lick, right? So there's no such thing as ghosts or, deities, anything like that in empiricism, right? Only things that we can interact with are real. So this word empirical means we have actual solid proof that this is the way it is. And the reason we use these, and the reason it's important that you learn them, is because if you've ever heard of a spectrometer or a spectroscope, like in CSI, you know about CSI? It's like an oldie show from when I was a baby.
I love it.
Yeah, and it's gross, and it makes you feel bad about yourself. But there's always like a guy, and they do like a cutscene, he gets his head squished with a hammer. Yeah. And then it was the maid, she did it all along. She was always squishing his head with a hammer this whole time. That's CSI in a nutshell. But basically what they do on this show a lot is they'll say, oh, we need to find out, they always talk like that. There's a lot of sexual tension in the show too, it's disgusting. But they'll say, we need to find out where this ash on his boots came from to see if he was at this gas station where he got his head squished in. And they go and they say, let's do some science to this ash. And they do the science and they say, yeah, he was definitely there. And that's all they ever show. But they say we're going to use the spectrometer. And the readout of a spectrometer will show this. A spectrometer will have all the little elements here. This is how you do the elements. And it'll have these little printouts and it'll say it's this much percent oxygen, this much percent hydrogen, this much percent carbon, and the readout will give you the percentages of that ash of each element, okay? So far you're with me, right? And you can see how this would be useful, because we just put some mystery goo into the machine, and it tells us these are the material it's made out of, right? So that's like Star Trek level stuff. You see what I'm talking about? You tracking with me? It's like 2 minutes into the lecture. You tracking with me though? So our information that we're going to be given for all of these is going to be element X percent, element Y percent, element Z percent. It can have 40 of them. 3 is usual. 3 is what most of the ones on your practice problems will have. But it'll tell you the percentage of each element. And your job is to find out what? Can you guess?
The percent?
No, you were given the percent. That would be a really easy problem.
Amount of each.
Well, that's a better guess. You get all these percentages and you're trying to find the
Whole thing.
I don't know.
The formula.
The formula! Thanks, Ty. That's why it's called empirical and molecular formula. And you know what a formula looks like, right? Like H2O, that's a formula. So we're trying to find the name of what this is. Because then we can say, oh, the ash was from this volcano where he went on vacation last year, or whatever, right? So we put in some mayonnaise, and it says the mayonnaise is this percent this percent this percent this, and we can say, oh, that mayonnaise is made out of water, mostly. Okay? So how do we do it? That's the question. I'm going to use one of your examples from your worksheet, because it's really hard to just think of these on our own. So this is number 1 on your worksheet, and let me just give you your worksheets real quick. Okay, we've returned. So here we go. An oxide of chromium, it says, is found to have the following percent composition. 68.4% chromium, 31.6% oxygen. Determine this compound's empirical formula. So this would be like the readout on our mass spectrometer, for instance. We would put in some weird blue salt, which is what this would look like. What's this weird blue salt? And it would print out this. It would say 68.4% chromium, 31.6% oxygen, and then we would just sit there and say, I don't know what to do. No, because we're going to learn what to do. Okay, so the first thing you do is you assume you have 100 grams of the substance. Why would that be convenient and nice.
100%.
100%. So basically what we do is we just make these percentages into what? If we assume we have 100 grams, these percentages become grams.
Decimals.
So the first thing we do, step one, is we find the moles of each let's put element. Because substance is technically correct, but we're always going to do this with elements. So find the moles of each element. So if we were obviously our actual readout was percentage, but we have what?
Grams.
Grams. So how are we going to find the moles if we have grams?
Convert grams to moles.
Yeah, just like we've been doing. 68.4 grams chromium. From grams chromium to moles chromium. What's my conversion factor? And how do I know?
Isn't it this? 6 point? What is it then?
For grams to moles, how do we find?
Oh, we have to take, it'd just be 68.4. No.
How do we find the molar mass of chromium?
1 mole
1 mole.
and 51.996.
He just made that up?
Yeah.
No, where do you find it?
On this.
On this, the periodic table, on the periodic table. Thank you for saying it might be Avogadro's number. Remember, Avogadro's number we only use when it's particles to moles or moles to particles. Whenever it's grams, whenever it's going to be mass, we have to use the molar mass, which we find on the periodic table.
Do we do it to 3 sig figs?
Yeah, we were given 3 sig figs, so we should use 3 sig figs in our answer, which is?
1.32 moles of.
Is that what everyone finds?
Yep.
Okay, thank you. Done with that step? Done with step 1, question mark?
Mm-hmm.
No. We have to also find the moles of
Oxygen.
oxygen. So 31.6 grams of oxygen. We're going to convert from grams of oxygen to moles of oxygen. In 1 mole of oxygen, there are, I know,
15.999.
999. And you have that memorized? You don't have to,
Yes. Yes.
but I have it memorized
I
on
have.
accident. Answer? Still 3 sig figs, or once again 3 sig figs.
1.98 moles.
1.98 moles. Lovely. This is an excellent result. Step 2. Divide all
1 point what? 998.
1.98.
divide all moles, divide all moles by the smallest. What is this going to effectively give us? If we divide them all by whichever one is the smallest, we're going to be getting a what?
A decimal? Oh, that's
Possibly.
A range.
No, I thought you were going to say the right answer. That's a hint. A ratio. It's going to give us a ratio. So if we have, which one of these is the smallest?
1.32.
So we're going to divide both by 1.32. So 1.984 oxygen. It's going to be 1.98 moles divided by 1.32 moles.
1.98. Where'd you get 1.0?
And then for chromium,
Divided by...
1.32 because it's the smallest.
And that's
Mole?
1.32
No,
divided
one.
by 1.32.
Yep, and so just for this, I leave off the element labels because look, it's going to cancel out. What's our unit going to be here?
Nothing.
No unit, right? It's a ratio. So what is 1.98 divided by 1.32? I could say, what is 1.98 moles divided by 1.32 moles?
And you have
Doesn't matter.
oxygen and this is chromium?
Yeah, we're
1.5
1.5. Unit?
moles.
No.
No
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 unit.
unit, 'cause it's a
1.5,
ratio.
it's a ratio.
Yeah.
And then chromium, so this one's going to be super easy, but it's 1.32 moles divided by 1.32 moles will give us 1. I was hoping this would happen. I didn't actually know it would, but I'm glad it did. Step 3, multiply all, I'm just going to say answers. Let's put ratios. Multiply all ratios by a coefficient so they are whole numbers. That's not how you spell numbers. So meaning that I have 1.5 here and 1 here. What could I multiply both of those by so that they're whole numbers?
2.
2, which would give me a ratio of what?
3 to
3
2.
over 2.
3.
2, 2.
So oxygen equals 3, chromium equals 2. Now I have a real good ratio, 3 to 2. What's the ratio, by the way, of hydrogens to oxygen in water? 2 to 1. So now that I have a ratio, can I find a formula?
Yes.
Yeah, so, but
Oxygen.
wait, don't get too ahead of yourself because what we're going to have to do is ensure, I'm going to put that. Ensure that, I was going to say metal, let's say ensure the cation is first, then write the formula.
Which would be Cr2O3.
Yep. Cr2.
How do you know if it's cation? If it's negative?
If it's a metal.
Metal.
So really, I probably, and they're not always going to be metal. We really, to be very specific, I should have said,
That's not metal.
ensure the more electropositive element is first, but you know what I mean. If I say cation, I mean the one that has a more positive charge.
I just
And in this
have
case,
a gut
carbon.
feeling. I'm like, oh yeah, that goes there.
Yeah, really you can. It's not the greatest way,
always know
but
the
the further
oxygens.
left it is on the periodic table, that one should be first.
And
But wait,
oxygens-
we're not quite done yet because this is empirical formula, and the only difference is that for molecular formula it can be the same. But check this out. The trouble arises when we have something like hydrogen peroxide. Tell me what's the formula of hydrogen peroxide?
Oh wait, hydrogen peroxide?
Yeah, what's
HO2?
but for the hydrogen to match, remember those are
Two.
charged, so it's
H2O2.
H2O2. Okay, so what's the ratio of hydrogens to oxygens?
1 to 1.
It's 2 to 2, which is also 1 to 1. So if we did this, when the answer was actually this, what would we find as the answer? We'd find 1 to 1,
Yeah.
right? But that's not the answer. It has to be H2O2. HO is a totally different thing, that's a HO, to H2O2, which is hydrogen peroxide, right?
Yeah.
Do you see what I mean?
No.
And so what this is called the molecular formula. Write this down, please. Molecular
So what's the
formula.
difference from that to what we have?
I'm going to tell you in a second. Formula.
Okay.
What would be the empirical formula of this? So if the
Uh,
what would this have found? The empirical
The
formula is always going to be the
ratio
lowest ratio,
of-
which is what? What would be the
It'd be
lowest
H.
ratio?
3 to 2.
Oh.
HO. The HO
Oh,
is the
okay.
empirical formula. And this is
But
obviously
this one couldn't
So
have
it
a
doesn't have the
molecule.
values?
right. It doesn't. It would be just the lowest ratio. The empirical formula is going to have the lowest ratio.
But for like the one we just found, it wouldn't have.
Right. This is the correct answer for this one. Because what's going to happen then is they will also give you to find molecular formula. Take the given molar mass and divide by the empirical molar mass.
Can you read that out loud?
Just give me 1 second, I'm not quite done yet. Multiply all subscripts by this number. I will read it in a second. It says, to find molecular formula, take the given molar mass, that means in your problem they will give you a molar mass, and divide by the empirical molar mass. Multiply all subscripts by this number. So when we do this, when we
What's
divide,
the number?
you'll get a whole number when you do this all the time. When you do this part, divide the given molar mass by the empirical molar mass, you'll always get a whole number. And then you multiply everything by that whole number.
Take the given molar mass and divide by imperial. So you have to find the imperial first.
Right, so for instance, if we wanted to find the empirical molar mass of this one down
I
here,
thought we just did.
we found the empirical formula. But if we wanted to find its molar mass, we would just add Cr times 2 plus O times 3, right? Just like we do when we find the molar mass of anything. And then that would give us a whole number, and we'd multiply everything by that. So let me see if I can find one on here that also does that. Look at number 5 on this worksheet. This will be our example problem for
So what did we
molar
just
mass.
find out? What was the project? we
The
did?
one we did a second ago with chromium and oxygen
Yes.
was empirical formula. And now we're going to do one for molecular formula. I'm going to erase this. Yes. So write down would you read the problem aloud while I do this, please, so that the microphone can hear you? Loudly.
A compound containing...
Louder.
Okay, somebody else do it.
Someone loud say it, please.
A compound containing 5.9265% hydrogen and 94.0735% oxygen has a molar mass of 34.01468 grams per mole. Determine the empirical and molecular formula of this compound.
Thank you. 94 point what? 0735?
Yeah.
Oxygen, and it has a molar mass.
34.01468.
Grams per mole. So this is all of our given information. We know it's this much hydrogen, this much oxygen, and now we have, like I said, there's a given molar mass. If there's not a given molar mass, as there wasn't in 1, what can we assume about it?
It'll be the lowest.
Yeah, it's already. The empirical formula and the molecular formula for that one is the lowest. But since it does give us this, we can either assume they're going to be different, and we're going to have to multiply it, which will be fine, or they're trying to trick us, which sometimes is the case. So, just as it was before with the empirical formula, step 1, hopefully you have it known, but tell me what step 1 is. What should I do first?
You should.
Convert percents to grams.
Yeah, so basically I just assume these are grams. Super easy.
Yes.
What should I do next?
Wait,
Convert
what would you-
grams to moles.
Yep, convert grams to moles. In 1 mole of hydrogen, there is 1.0079 grams of hydrogen. Is that not right?
No, it is. You're just going fast. I'm just trying to get all of it. Did you say 1.0079?
I think so. That's what my memory tells me, but that not
And
always
you
is
end up
correct.
with mole of hydrogen.
Yep. And then I've done the same thing for oxygen. So this is the setup for converting the mass in grams that we were given to the moles.
4. It's 94. I had 92. 94.9.
How many sig figs?
Oh, looks like
6, 7?
6. It's 5.
Because the grams per mole has 7.
Oh, yeah, we only use the lowest significant figures. We can only use the one that has the least significant figures.
1 mole.
Okay, so 5?
I think 5.
Okay.
How are you finding it out on your calculator?
Yeah, it's 5, for hydrogen, 5.8800 moles of hydrogen.
8800. Okay. 5.8800.
Okay.
Yeah.
And then for oxygen?
94.0735. 5.87, or actually 5.8800.
Ooh, that's beautiful. What a crisp answer, because look at this. What's going to happen, obviously?
It's just going to be
1 to
1.
1.
It's 1 to 1.
It's just
So,
going to be HO.
We could show the step of dividing moles of hydrogen by moles, but we know that 5.8800 divided by 5.8800 is 1. And
This
similarly,
was a trick one. Like you said.
not quite, because look, we're going to get our formula of HO.
Yep.
Now, we haven't done the last step. There's a step 6 for molecular mass, because that's why it gives us the molar mass for this. Sorry, the molecular formula. That's why they give us molar mass. Because
Yeah,
look, now we have to find our molar mass. What would that be? H and O. Well, 1.0079 grams per
And
mole.
then
15.
So now we're finding
0.999.
molecule.
We're trying molecular mass. So for HO, that should be about 16.0078.
Did you grab some?
17.0069.
I'm sorry. 17.0069. Why am I the way I am? 17.0069?
Yes.
0069 grams.
I don't know, Ty. Because I know that 9 plus 9 is going to give me 18.
1.0079.
Doesn't matter. This will be close enough.
I use calculator.
Okay. Did you though?
Yes.
17.0069. Okay.
Okay.
And now that's.
Now this is our empirical molar mass, and we were given a molecular mass or a molar mass, right? So what was the molar mass we were given?
34.014.
So now we take 34.01468 grams per mole divided by 17.0069 grams per mole, and this will always give us a whole number, or so close to a whole number we can consider it a whole number. I already know
It's
it's
going to be 2.
It's going to be 2. 2. So now we multiply all subscripts by this number. So instead of being Ho, it is,
H2O2.
which happens to be, name it.
Hydrogen peroxide.
Hydrogen peroxide.
So I'm confused because this